Okay. So I'm available now. Every one of you able to see my screen and able to hear me?
Yes, sir.
Yes.
Okay. Someone came to talk to me. That's why it got delayed for 3 minutes. Just please stay connected. Just give me 1 minute. Okay. Okay. Let's resume our sessions now. Last class, what are we discussing about? In the last class, we were discussing about OOPS concepts. So conceptually, you should have knowledge about object-oriented programming system things. So where you are going to learn about or understand about these things, like first one is encapsulation. And encapsulation is a concept in object-oriented programming system where the concept can be implemented by the programming languages, Java, C++, Python, all that. They have implemented it and named it as class. So encapsulation class, both are not different. Both are same. Okay. And inheritance. So inheritance is a concept which achieves the reusability. So if you want to achieve reusability, create one component somewhere, access it at multiple places, you want to achieve that, this is going to be possible by inheritance concept. So in inheritance, we have to there are many like single, multi, multiple, hierarchical. I'm not going to talk about all that. What is necessary for us in Pega, I'm going to talk about it. Now, single level inheritance, multi-level. Single level inheritance means parent and one child, one parent, one child. Multi-level means child to parent, grandparent, grandparent, great grand, like that, n number of levels. It's like a chain. It's like a chain that is called multi-level inheritance. So let's talk about OOTB classes. See, there are so many OOTB features available in Pega. Those OOTB features means rules, OOTB rules. Definitely, these should be available in OOTB application. That application cannot contain this OOTB rules directly. It should be there inside class. So a functional component will be created inside a class. That class will be there inside an application. So in the same way, Pega has Pega platform application, OOTB application, in which we have so many OOTB classes. Okay. And these OOTB, out of these OOTB classes, the most important classes are @base class, work dash, data dash, int dash, code dash, system dash, rule dash, index dash, embed dash, assign dash, etc. Okay. And you don't need to by heart or remember these things. Okay. Automatically, you start remembering when you practice these things many times. Now, out of these all OOTB classes, @base class is topmost class in Pega. @base class is topmost class in Pega. Okay, remaining all are children grad, like that. And now, whenever you want to create a class, you can create a class, but while creating, there is an option to choose the type of a class. So in the real world business, we need different types of departments. Some departments can have the ability to initiate transaction or right to initiate transaction, and some departments should not have that ability to initiate transaction. So authority is there, authority not there. Both type of departments we want. So when you bring that into real world, you need to term the departments as classes, right? So now you need two types of classes where the classes should have the ability to to initiate a transaction and shouldn't have any ability to initiate a transaction. So the classes types are what is that? Abstract and concrete. Abstract and concrete. Abstract classes cannot be instantiated. Means you cannot initiate a transaction in the abstract class. Concrete classes can be instantiated. That means you can initiate a transaction in the concrete classes. Understand clear, everyone? So that's what I have explained you in the last class. Every one of you, are you clear with the points that we have discussed in the last class? Any doubts from last class? Everyone clear? So conceptually you need to understand it, and comparison with real world also should be there. Why we need this type of class? Why we need that type of class? Why we need inheritance? Because in order to achieve reusability, easy to extend, and in order to reduce the time and all, and also to save money, you can depend on inheritance concept. And now the inheritance, how it is implemented in Pega. That's what we need to learn. So before we look at the inheritance in Pega, we need to look at the classes created automatically by application wizard. What are the classes created? See, it got created and we are going to utilize it in the classes. We are going to create some functional components. But before you proceed to do that, you should have some idea about the existing structure. That's what I told you. So you got a new bike. Before you start using riding on the bike, you must have to have the idea about, so what functional components are available where and what is the architecture of it. So in the same way, the application which we have created, let's log into our application. So here you go now. What is your application name? BCBS, right? devimpl@bcbs.com password rules. See, it is implementation application. I'm sorry. I think I'll do one thing. Give me 1 minute. Okay. So next time onwards, I can take it from there. devimpl@bcbs.com password rules. And here you go now. So let's go to our application. When you log into your application, you'll be getting App Studio. By default, what is the studio you get? So I did not tell you anything about studios as of now, but let me finish these concepts. Then I will give you some brief idea about the studios. And from App Studio, you usually switch to Dev Studio. Dev stands for development. Okay. App stands for application. Okay. And here you go now. When you log into this one, you come to App Explorer. Okay. App Explorer. There you see classes. Here classes, created classes you can see. How many classes got created? Is it 1 or 2 or 3? No. There are many classes got created. Okay. So around 12 to 15 classes got created. Those classes created by your application wizard. See, you executed a new application wizard, no? When you execute new application wizard, so the new application wizard has created some number of classes. You don't need to focus on all the classes today itself. You need to focus on only 3 levels of classes, which I am going to tell you. When you come to App Explorer, here you see classes got loaded. This is loaded, right? Just if I remove and then again tap, that is also getting, that is only getting loaded. So I will copy this name and paste here in the notepad. Okay. And also I will take it in a document, because for this, you definitely need a document to understand. Just give me 1 minute. Here you go now. The classes. Okay. So when we run new application wizard, Pega has created below classes. So these are not OOTB. See, OOTB means that comes along with Pega platform. OOTB means that comes along with Pega platform. So any action you do on Pega platform, as a result of it, something is created, means that is user defined, that you created it. So these classes got created when we run new application wizard. That means these classes created by you are OOTB. Huh? So when you run new application wizard, some number of classes got created, right? Those classes are created by you or OOTB? By OOTB. You only. It's not OOTB. You performed an action of running a wizard. The wizard has automatically created some number of classes. OOTB means very simple. Installation. Installation of Pega you did know. When you install Pega, whatever came is OOTB. After that, anything is been created by wizard or whatever the way, it is user defined only. It is user defined only. When we create a new application, Pega has created below classes. What are the classes it has created? These are the classes. How many? So many created, out of which these 3 will focus on. So how many are there in this name? Total, how many are there? 3 classes are there. Okay. These are, okay. This is called as class group. This is called as class group, just for your information. Technically, what is the definition of class group? I'll tell you later. But for now, what you need to understand is, okay, this is class group. These 3 combination is there, no? This is class group where transaction gets initiated, processed, and finally it gets closed here. Now tell me one thing. If transaction is getting initiated, means that is concrete or abstract? Transaction getting initiated.
Concrete.
Transaction can be initiated in concrete class. Transaction can be initiated in which class? Concrete class. Definitely this should be concrete class. Is it one class or multiple? I will tell you. So BCBS is one class. These are three classes. How many? Three classes. First one, BCBS. It is same name as something else. See, here you go now. BCBS. If you want to access BCBS, see, you need to backspace here. You need to backspace here up to BCBS and choose it. This is BCBS class. Every time instead of backspacing, you can use pin icon. If you pin it, it will be added in the shortcuts. Just give me 1 minute. It is getting added into shortcut. So next time when you log in and come here, class group will be loaded, but BCBS you can see in the shortcuts. Okay. So anyhow, we will see from here only. So I am trying to show you what is already there. So BCBS class is there. I want to know what type of class Pega has created. Okay, let me take the screenshot. Just give me 1 minute, please. And here you go now. Let's save this document first of all. 628, right? Batch number 628, June 18. Save. Okay, and here you go, BCBS. Now do what? This BCBS class, I have three classes. First one BCBS, second one is BCBS Auto. I'm sorry. BCBS Auto. Third one is work. Three classes. And now let's go to first one, BCBS. BCBS. Let's have a look at its definition. So right click on class name, then choose definition. If you want to know the details of any rule in Pega, you just need to go to its definition. You just need to go to its definition. This is BCBS, right? You right click on it, use your mouse, right click and choose definition. And you see here what type of class it is. We did not select it. Pega has selected it automatically. This is being created as an abstract class. And this class name is equivalent to some name that we have experienced while creating new application wizard. BCBS is the name of
organization.
Name of our organization. Name of our
Organization.
Applications organization. So here with same name, one class has got created. One class has got created. So the class BCBS is said to be organization class. Which class? Organization level of class. This is topmost class of our application. And this is a common class between FW and IMPL
implementation
applications. Because common organization we have used, we will go to framework application in some time. Okay, first let's stick to implementation for some time. So here you go. Second one, what is the second class? BCBS Auto. And you look at here, BCBS is class name. Here you can see ID. ID is also same. I told you now, for everything you create in Pega, there will be a label and ID. There will be a label and ID. For everything you create in Pega, label and ID. Label is for display purpose. ID is actual recognition by the system. The PRPC is going to recognize every rule by its ID. Label is for display purpose. ID you cannot change it. Label you can modify if you want. Okay, now here you go now. BCBS Auto is the label and definition. When you go to BCBS Auto and its name ID is not BCBS Auto. It is BCBS Auto. Previous to that, BCBS hyphen is there. I'll talk about this in a minute. But now this is what type of class? This is abstract class. BCBS Auto. And this is also created as abstract class. This is division level. This is when you compare with organization, this is division level. And now you look at here. I logged into implementation application, right? I can see the details of an application into which I have logged in. I want to see the details of implementation application. Where can I see that? Here is your application menu, correct? BCBS insurance, auto insurance. Click on this and go to definition. So BCBS application ID is BCBS Auto. Implementation application is BCBS Auto Insurance. For it, the ID I have shown you while creating new application, right? The ID is BCBS Auto, correct? So the BCBS Auto is ID. The name of implementation application and the class name, division class name, both are same. Pega has taken both as same. So this second level class, whatever we have, second level, this is also called as application class. What do you call it? Because its name is same as implementation application ID. Implementation application ID. So implementation application class. Implementation. This is also called as implementation application. First level class, you are saying it as organization class. Why? Its name is same as organization name and it is topmost. Second one, of course, it is division level, but it is called as application class. Why it is application class? Because its name is matching with application name. That Pega is taking like that. And third level, let's see, work class. What is the third level? Work class. Go to work class. Inside BCBS Auto, you have work. Other classes I am not going to focus on. Work, right click on work class and see definition. And this class, if you observe, this is a concrete class. This is a concrete class. This is created as concrete class. Just let me tell you one thing here. And here you go now, new application wizard. In the new application wizard, you are giving some name to the application. So you are just clicking on something and thereby you choose something and use some name and then advanced. You see the class name is created as work. See, it is possible to modify it. But at the time of while we created, it has given as work. I did not modify. If you want to modify, you can modify. You could have modified. But I did not modify that. So by default, Pega is taking the name of unit level class. What is that? In the organization structure, this is unit level class. Yes or no? And its name Pega is automatically choosing as work. I could have changed it, but I did not change it. What is the meaning of work? Work means transaction. Work means what? In other words, it can be called as transaction. You have done a work. You have done a transaction. Okay. So meaningfully, Pega has taken the name as work because this is a concrete class. This is where your transaction gets initiated. This is where your transaction gets initiated. This is where a transaction can be initiated in implementation application. In implementation application, you can initiate transaction from work class. This class is called as class group. You can say class group, mainly technical terminology, class group, or you can also simply say work class, or you can say transaction class. Okay. So yeah, like this different terminology you can use. Remember this terminology or this one. First two most widely being used. So Pega has created so many classes along with application, out of which while logging to implementation application, you are focusing on 3 classes to know about: organization class, implementation application class, and work class or class group. Okay, clear every one of you? Are you clear with what is there and what type of classes these are and what levels of classes these are? Are you clear about this, everyone?
Yes.
Yes.
Okay. Okay. Very good. Now, next we are going to look at inheritance concept. Okay. In Pega, how to achieve it? How to access a rule from one class to another class in Pega? Okay. In Pega or C++ or Java, anywhere, inheritance is must. Through inheritance relation only, you can access a component from one class to another class. So now, I want to access organization class rules into division and units. Yes or no? I want to achieve that. Higher level to lower level. See, if we look at a family, in a family, child, father, grandfather, great grandfather, forefathers, right? All these are belongs to same family. So suppose if you take some other family, definitely there can be no relation. That's again different tree. So one family is equal to one application. One family is equal to One application. That blood relation is chain. Blood relation is chain bottom to top. You always look from bottom to top, not from top to bottom. Bottom to top means your focus should always be on work class. Work class is a center point. Suppose you take solar system. What is the center point? Sun. So if you talk about any other planet, you talk with respect to sun only. So if you are talking about any class here in our application, you talk with respect to work class. From work class, above parent, parent, like that only you'll see. So transaction class is the main class. From that, it has a parent, grandparent, like that you have to say. Now, work class, above the work class, you have BCBS auto. Above BCBS auto, you have BCBS. How can work class access the features from organization and division? Through inheritance. Then how the inheritance can be defined in Pega? In Pega, inheritance can be defined by a symbol hyphen. What is the symbol? Hyphen. Okay, suppose you have a class E. Class is A. One class by name A. Now you want to create class by name B. But you want B to be child of A. Then how do you create, you know? While creating B, you create it like A dash B. I will tell you. Look at here. So just simply don't bother about the navigations. Just simply BCBS after I want to create one class. Just like that. That class should become child of BCBS. Now right click on BCBS. Don't bother about the navigations now because this is not the class about session about navigations. It's a session about concept. Okay. So now automatically BCBS name is coming as I have right clicked on BCBS. After BCBS, I will give a hyphen and I'll give, let's say, ABC. ABC is the name of the class. Okay. Label and ID also same. Now I am creating a class. Save this, done. Oh, I'm sorry. I'll just choose these things. Some of the things I'll fill. Class is created. But you see the ID of the class is ABC is a class. Actually, ABC is a class, ABC. But its display name, its ID is BCBS-ABC. That means you created ABC class inheriting from BCBS, where to define inheritance relation, you have used a hyphen. You have used a hyphen. That hyphen, you call it as dash. What do you call it? Dash. Dash defines inheritance relation between the current class with its higher classes. Okay. So this type of inheritance in Pega is called as pattern inheritance. Inheritance in Pega. There are two types. How many types of inheritances are there? Two types. Two types are there. First one, pattern inheritance. Let's discuss more about this. Pattern inheritance is there. Now, just from here onwards, everyone should fully focus here. Don't get confused anything. Just you need to understand it clearly. Fully focus here. Pattern inheritance. So this inheritance can be defined between classes by using dash. By using what? Dash. By using dash. So see, inheritance is inheritance. Whether it is pattern or direct, inheritance is inheritance. That means inheritance means accessing features of parent to child by defining inheritance relation. Pattern means the inheritance can be defined between classes using dash. Okay. So we can make the higher level classes as parents to bottom level classes. Through pattern inheritance, we can make the higher level classes as parents to bottom level, like our family relation. Same, higher to lower, like that. And here, these classes, these parent and the child classes, belongs to same application, same family. No, blood relation higher level to lower level means definitely same family. So belongs to same application. Understand clear, everyone? Online students, are you clear?
Yes, sir.
Okay. Now pattern inheritance, if you are clear, we are going to jump on to direct inheritance. Just listen to it. Listen to me carefully. See, I have application A, application B. Two applications are there. Two are created on top of Pega platform. Two applications are created on top of Pega platform only. Just imagine. And here there is a class. And here one class is there. Is it possible to access the components of this class into this class? Is it possible? It should be possible only when you define inheritance relation. So first you need to define inheritance relation. See, within one single application, two classes are there. Suppose in a single application, two classes are there. Is it possible to access the components of class A into class B, where both classes belongs to same application? Is it directly possible without inheritance? Without inheritance, is it possible?
No.
No. So both belongs to same application, but still inheritance relation must be there. In such case, both belongs to different application. Is it possible to access without inheritance? No, it is not possible to access. So you have to first define inheritance relation. You have to first define inheritance relation. Then only you will be able to access it. Correct? Okay. Now, is it possible to define inheritance relation between two classes which belongs to different applications where there is no relation between applications? It is not possible. So let me write down one point. Before this, I will write some points here. Okay, direct inheritance, right? Direct inheritance. Okay. Before that, I'll just give a note. It is possible to define inheritance relation between two classes when they are part of same application. This is first point I am writing. Okay, just for your information. It is possible. It is very well possible when they are part of same application. That is, you are going to do it by pattern inheritance. What type of inheritance? Pattern. And next one. It is not possible to define inheritance. I'm talking about defining inheritance relation. Define inheritance relation. Inheritance relation between two classes of different applications. Means what? These two applications are not connected in any manner. In any manner, these are not connected at all. Okay. So it is not possible to define inheritance relation between two classes of different applications where these two classes are two applications. These two applications are not connected in any manner. There is no relation between two separate applications on Pega platform. You cannot even define inheritance relation. You cannot. Now, third point. It is possible to define. It is possible to define inheritance relation between two classes of different applications when an application, otherwise I'll write down like this. Application A is created on top of, otherwise application B I'll take. When application B is created on top of application A. Application A. Okay. Understand? So if you want to define inheritance relation between two classes of two different applications, these two applications have to be created one on top of another. Like how you created implementation application on top of framework. See, you can, without inheritance, it is not possible. See, if you create two applications one on top of another, it doesn't mean the child application can access all the features of parent application. No. Unless you define inheritance relation between classes, you cannot access. Two applications are connected, but there is no inheritance relation between the classes. Still, you cannot access. Defining inheritance relation is possible when the applications are connected. Applications are connected, then you get an ability to define inheritance relation. Applications are not connected, you cannot even define inheritance relation. So from this, what we can say is, we can define from the above points, from the above statements, we can achieve below. We can achieve the below. What we can achieve? So our framework application, we can define inheritance relation between framework application classes with which application? Pega platform application classes, where FW is created on top of Pega platform, of
Pega
course.
platform.
Correct? Yes or no? Online
Yes.
students, yes or no?
Yes.
It is, see, I'm not talking about accessing part. I'm talking about defining relation part. You need to understand. First you define relation, then accessing next. Defining relation possibility will be there only when you have applications created one on top of another. So you can define inheritance relation between framework application classes with Pega platform. It is possible because your framework is created on top of Pega platform. So this is what I'm talking about. See, I'll just draft this one diagram. Just see, the explanation is taking time. Just here you go now, and here you go. This is Pega, this is framework. No? So this is framework, FW app, and what is this one? Pega platform.
Pega
Just for
platform.
you. So there is a class in framework, class B. What is that? Class B. Class B. And here we have a class in Pega platform, that is class A. You created one on top of another, right? So does it mean class B can access anything from class A directly? No, it cannot. Unless you define relation, it is not possible. You have to first do what? Define inheritance relation between these two, then only accessibility will be possible. This defining is possible here because created one on top of another. Suppose if you create these two separately, then it's not possible to define inheritance relation. Understand? Everyone clear? So defining inheritance relation between two different classes of two different applications, where one is built on application. This is called as, what is this called as? Built on application. Built on. So for framework is built on top of Pega platform. Correct? That's why Pega platform is also called as built on application. Understand? So a class can access the rules of its built on application classes only when there is inheritance relation defined. So this way of defining inheritance relation is called direct inheritance. What is this called as? Direct. This means two different families. Okay. This is different family. This is different family. So you are trying to make an inheritance relation between two different families. You want to access the property of another family into your family. That is by marriage relation. Direct relation between two families by marriage relation. So this guy, one family can access the property of another family through marriage relation. So you can understand blood relation is there, no? Same family, that is pattern inheritance. Some other family you are accessing the property, suppose. So in India, how it works, like marriage relation. Some property she will get, so that can be accessed here. So that's called direct relation. So this is direct inheritance defined. So there is a purpose for each type of inheritance. See, if you want to access the features of higher classes to lower classes where classes belongs to same application, so it is possible by pattern inheritance. So I want to access the features of built on application classes into current application. So it is not possible by pattern, no, because built on another application, how it will come in the pattern? No, it cannot come in the blood relation, right? Then how do you access? You define another type of inheritance relation. What is the other type of inheritance now? Direct inheritance. Understand clear, everyone? Online students, are you clear with this point? Where is it?
Yes.
Direct inheritance. See, this is what you need to understand. So direct inheritance, it is an inheritance relation defined between the classes of current application. Between current application means I'm talking about lower level. I mean like implementation. If you log into current application, between current application classes with its correct built on. What is that? Built on That means you can understand it like framework. Okay, built on means with its built on application classes. So why Pega has two inheritances, you know? One is to access current application, another one is to access OOTP application. See, Pega platform is an OOTP application. It has so many OOTP features in its OOTP classes, which I want to access. No. See, at the rate base class, there is send email notification. I want to access OOTP functional component into my application classes. How is it possible? That is a different application. No? I need to define inheritance. It is not going to come in the tree of my application classes tree. In class tree, it will not come. Then it is not possible by pattern inheritance. Then what type of inheritance you have to depend on? So define direct inheritance between built on application classes with current application classes. Then only it is possible. Understand clear? Online students, are you clear?
Yes.
Okay. So there is a purpose or need to have two different types of inheritance. In interviews, they will ask you a question. Why Pega has two different types of inheritance? What is the reason? What is the reason Pega has pattern inheritance as well as direct inheritance? Anything is inheritance only, na? Why not only one? What do you answer then? You have to answer like, in order to access the higher level classes to lower level classes in the same application, Pega has pattern inheritance. As built on application classes will not be available in pattern, so that is possible to access Pega platform features can be accessed into framework application by using direct inheritance. Framework application classes can be accessed into implementation application classes by using direct inheritance. So framework application can access the Pega platform features through direct inheritance. And what else? So second one, implementation application classes can access
Framework application.
can access the rules of the Pega. Can access the rules of okay, just give me 1 minute. Can access the rules of framework and Pega platform application classes features through the features and so framework application classes can access the rules of Pega platform classes through direct inheritance. In the same manner, implementation application classes can access the rules of framework and Pega platform application classes through both. Implementation application can access the features of framework application classes as well as Pega platform when there is direct inheritance relation defined. Without defining, is it possible? No. Okay. So let's see whether it is being possible or not. We are done with this, no, up to here. Now let's have a look at these things. So direct inheritance. For direct inheritance, I will give the screenshots because pattern no need to give. No, pattern means class naming pattern easy. Direct inheritance. Okay, direct inheritance. So where do you define direct inheritance? One more point I should write. We can define the direct inheritance relation between two classes, between direct inheritance relation in the class definition. So if you want to define pattern inheritance, how did you do that? By hyphen. Simply dash a dash b, a dash b dash c, a dash b dash c dash d. Like that, you can have any length. So direct inheritance, where do you define? So class A, class B. Suppose for class B, you want to make class A as direct parent, not pattern. Leave about pattern, forget about. So where can you define that relation? That is in the class definition of B. Go to the definition of B. There you should see inheritance and mention class A name there. Look at here now. So I logged into implementation application, correct? So now in the direct inheritance part, I am not going to talk about organization division. I will talk about these things later. I will focus only on one class, work class. So right click on the work class, definition. So let me look at direct inheritance, implementation, class groups, direct parent. Let's have a look at it. So what is already been chosen by Pega? Let's have a look at that. Scroll down. You see parent class directed. This checkbox I will tell you after a month. You'll be focusing on this drop down. So by default, Pega has chosen the direct parent of implementation class group as work dash cover dash. What is this work dash cover dash? Work dash cover dash, for your information. Sorry. Work dash cover dash is an OOTB class. From Pega platform. Which means that our implementation application transaction class can access the features of Pega platform's work dash cover dash class. Yes or no? Just let me draw the diagram for the same. Just let me close all these things. Okay, so this diagram I will save. The one which I am going to create now, I will be saving this diagram for our reference purpose. So present, after you run new application wizard, how direct inheritance is defined. That's what we are trying to know about. So here you go now. This is Pega platforms work dash cover dash, correct? Work dash. These are two classes actually. Work dash cover dash is child of work dash. Work dash is again child of base class. Okay. So I will talk about that later. Now let's come to implementation class group. This is our implementation class group. Take implementation class group. This is IMPL class group, transaction class, or you say transaction class. That's where transaction. So now this is been inherited. This has been inherited from work dash cover dash. What type of inheritance it is? This is direct inheritance. This arrow mark here in this scenario is direct inheritance. Okay. So let me write down direct inheritance diagram, right? Direct inheritance diagram. Right. Okay. This is what we have. From this, what we can understand. Just give me 1 minute. I'll save this diagram. It was a 628, right? 628 direct inheritance diagram. Okay. Now, this is clear, everyone. This is what Pega has chosen. So far, we talked about only implementation class group. What about framework application class group? So when you create a new application, framework application, there also class group would have got created. And for that class group, topmost class is BCBS, common class. So how can I access the definition of framework class group? Is it that I have to log into framework application to see that? No need, because implementation application has the visibility to see anything in the framework application, Understand? So now you can access framework application class group here itself. How? See, I know it. That's why I'm telling you. See, any class names have FW in it. It stands for those classes are related to framework application. That's a convention that Pega follows. FW is to give you a sense these classes belongs to framework application. So you see, this is framework application. This is framework. This is frame. In framework also you have one work class. If you look at this framework application class group, let's have document here. FW application class group. This is a one. How many classes are there in this class group? Total 4. You see BCBS. This is a common class between framework and implement. After that, FW, this is different. And BCBS INSU, this is different. Work. This work, implementation work, both are different, not same. I will tell you. You see the tree diagram. Tree, if you understand, you can understand that. See now, BCBS, right? BCBS. Under BCBS, you have BCBS Auto I. And below that, you have work. And again, BCBS after FW.
FW.
And after FW, you have BCBS insurance, something. And then you have work. Okay, here you go now. This is pattern inheritance. What I'm drawing here is, so this is what we have got when we create a new framework. And this work is different. This work is different. So all these are 5 different classes. Common class here is BCBS. Framework and implementation common class is BCBS. Just I will give this diagram also. Just give me class groups of 2 apps. For 2 apps, these are the class groups and common class is there. So you don't think like this work is same as the other work. No, different. That is a different class. This is a different class without any relation. Common class is there because we have chosen common organization. Now let's look at the definition of this one. Okay, let me close implementation part and framework application class group definition. I think we have 10 more minutes. Maybe that is sufficient or not to wind up this direct inheritance. Not very much sure. Okay, we can cover it. Okay, done. So now for framework application, for FW application class group, the direct parent is, sorry, what is that? Work dash, same direct parent. By default, Pega is taking like that. Same I am going to draw here in the diagram. So now I am going to extend this diagram like this. Framework, this is framework class group. No, here you go now. So this is framework class group. Just give me 1 minute. I'll copy from here. And here you go now. And here FW application class group or transaction class. That is what we have got. And now for this, the inheritance is like this one. This is by default wizard provided. Sometimes wizard may not be able to provide you everything as you want. You may correct it. Diagrammatically, this is what we have. From the diagram, one thing you can understand that our implementation application class group can access the features of framework class group. So, sorry. Our implementation application class group can access the features of Pega platform some class work dash cover dash. Framework class group can access the features of Pega platform work dash cover dash. But implementation application class group cannot access the features of framework class group. Can or cannot? It cannot. Why it cannot? Just look at the diagram and tell me. There is no inheritance relation defined between implementation application class group with the framework. So by default, Pega is not giving this. It is missing something. The wizard is not giving this. So we need to correct it. So now you know what we want to achieve. Okay, let me write down the same thing here. Just let me take it from the previous session document instead of typing 626, right? Previous one, 627. Okay. Somewhere it should be available. This is class requirements. Huh? Okay. Okay, just give me 1 minute. Okay. You can see, I think I did not draft here. Interface. Okay, so I did not draft here. Like here you go now. See, from the diagram, what we can understand. We can understand this. Understand this. First one, FW application class group can access the features of Features means rules. The rules of work dash, cover dash. Work dash, cover dash. And implementation application class group. Application class group can access the rules of work dash, cover dash. These two are possible. So, but what we want to achieve, implementation application class group cannot access the rules of FW application class group, but we want it. We want this to happen. So we need this one also, because implementation application you created on top of framework application to access its rules, right? So, but it is not possible because there is no inheritance. Pega is not giving. So we want to achieve that implementation class group should be able to access a framework class group, but you cannot provide like this. You cannot do like this. So if you go to implementation application class group definition, and there is already one class mentioned in the direct inheritance, comma, one more class, it is not possible. So in the direct inheritance, you can mention only one class. Two you cannot mention. Keep this point in mind. Understand? So now diagrammatically, let's modify it. Diagrammatically, let's modify what you want to achieve. You know what am I going to do? I am going to remove the connector. One connector I am going to remove. From Pega platform, work dash, cover dash, direct inheritance is there, no? I am going to remove this connector. I'm going to remove this connector. Pega platforms, work dash, cover dash to implementation I have removed. And now I am making a connector from framework class group to implementation class group. Diagrammatically, I am making a change. When I do this, now from this diagram, we can say one thing, that still framework class group can access the features of work dash, cover dash. Implementation class group can access the features of framework class group. Yes or no? From this diagram. Now, third question. Can implementation class group access the features of work dash, cover dash also? Yes or no? Yes, how?
Because there is a relationship.
How it is yes? That is, how it is yes? That is parent of parent. Parent of, in the direct inheritance, you have multiple levels. Direct also multiple levels can direct parent. Direct parent can have another direct parent. So parent of parent is also parent. That's what we discussed in multi-level. Here you are experiencing multi-level for what type of inheritance? Direct inheritance. So implementation class group can access the features of Pega platform through parent of parent. So let's achieve the same. Let's do it practically. This is today's practical, only just simple thing. Implementation application class group definition. Class group. So how do you go to implementation application class groups definition? Right click on this and go to definition, and you see this window where you are going to click the down arrow, and you see parent class directed was mentioned as work dash, cover dash. Remove work dash, cover dash and choose framework class group. Means it should be listed below. Remove it, click the down arrow and type BCBS. Type BCBS to highlight this and search here. FW related classes also coming. Choose what? This is one correction we have made, which the wizard is not giving by default. Wizard, if wizard has given this, I would not have touched this. Correct? So in the direct inheritance, one change we have made, that is choosing the right appropriate class. Okay, makes sense? Clear, everyone? This is the practical for you. Just but before you do this, you need to understand the concept. What's going on there, Ashwini? Please be on mute. Okay. Yes. Now, are you clear about pattern inheritance and direct inheritance? Are you clear? So after explanation of pattern plus direct, you have modified one thing, that implementation class group direct parent as framework class group. Framework class group direct parent is already work dash, cover dash. Through this direct inheritance multi-level, implementation class group can access work dash cover dash Pega platform also. This is one correction you have to make, as the wizard has not provided. We need to correct it. Listen to this session once again. While you are listening, write down the important points. What are the key points? You just please make a note of it. And you will be able to realize all these things when you practice. When you are doing practicals, you will be able to understand all these things. So, how to access this inheritance relation rules and all from parent to child, I will show you practically. Okay. So, with this, we are done with theory. Tomorrow, I am going to kickstart about creating a new web page. You want to create a new screen. Okay, how can you create that? If you want to create a new screen, what are the different rules that you can make use of? Understand clear, everyone? So that's what we are going to see tomorrow.
I have a doubt.
Tomorrow is going to be a new beginning. Tomorrow is going to be a, so this is all introduction. So application creation, what is created, inheritance, this is all one part. Tomorrow is a new beginning, which is connected to this one again. New beginning means that is a new requirement, new rule and all. Yes, please.
Suppose we have 7 applications. The Pega platform and framework. The remaining applications are
The remaining applications are
implementation application, or is it a framework on top of
on top of Pega platform? You have a framework, right? On top of your framework, you can create one more framework. So when you create an implementation, that is a stop point. From there, you will create side by side all implementations. You can have a number of layers of frameworks. Depends on how large business you are having. Okay. Pega platform is already a framework. On top of it, one more framework is there. You can have one more framework. Multiple frameworks. Once you have implementation created, from that moment, you will not see increasing stack. You will see side by side all implementations. Okay. So slowly you will be able to understand all these things. Just give time. No, that is a wrong design. Okay. You should not create an implementation on top of another implementation. That will become the defect in the design. One implementation can come from one framework or more than one you are asking about.
Can we access from one implementation?
No, you cannot access. So implementations are side by side, right? Siblings. Two implementations are siblings. One implementation cannot access features from. You cannot even define inheritance relation. Simple, because these are two separated, no? Okay. Just draw the diagrams by yourself. While of course, I'll share these diagrams. And today, as I told you, is the last session for free class cut. And by tomorrow, only the students who have completed, made the fees payments are allowed. Okay. Other students have to stay back, and meeting link will be changed generally. Okay. That's what going to happen. And you just watch your WhatsApp for the follow-up message. You can wind up for today. We'll continue tomorrow. Thank you for joining, everyone.